You can freely download this practical notebook from my website. From its home page, go to middle left and click Books and Notes. A new web page will open. Then download third book in PDF format. Experiment 18 on page 67 in the practical notebook. Left side page of same experiment.
I am going to perform an experiment for intermediate student about finding the refractive index of a material, and in this case we find the refractive index of glass. The experiment today is to find the refractive index of a material of a prism by critical angle method. The apparatus included is a prism, pins, a drawing board and a sheet of paper. This is a wooden board, sheet of paper, pins, prism, glass prism, few paper pins, a pencil, a sharpener, a ruler and a protractor. The prism having boundary A, B, C and a pin at point P on the face AB. Now we look its image. The image of pin P is from the other side or the face AC at the point Q. But we move our eye from point C towards A and put two pins R and S in line with the image where the image goes faint. You will see from the right side the clear image of the pin, and as we move from right to left, the image goes faint, and further moving it disappears at all. Now we fix a pin at a point where we see the dull image, and this is another pin in line with the image and the first pin. After removing prism from the paper, now we join point image of the two pins, joining R and S at a point Q on the boundary. Next step is to draw a perpendicular on the face BC at point P. Now we draw perpendicular on the line BC, perpendicular passing through point P. This point is O, and cut this line equal to OP, which is another point L. From L, join L and Q. Let this line cuts at point M, the boundary BC, and we now join point P and M. The angle formed at M, that is PMQ, can be measured
using this protractor, and this angle is equal to angle P and Q. Keeping this line parallel to PM, this line will measure the angle PQM. The angle P and Q measured from the ray diagram comes out to be 81 degree. Since we want to find the critical angle is the half of P and Q, which comes out to be 40.5 degree. Now take two more similar reading, and taking their mean, the angle comes out to be 40 degree. Since we want to find the refractive index of the material of the prism, the formula is N, the refractive index, is equal to 1 over sine of the critical angle, which is 1 over sine of 40, and we get the refractive index of glass equal to 1.5. General sources of errors are students should place these pins exactly vertical. While putting the pins should be vertical. This is the wrong method, and now this is the correct one. Good. For best result, the boundary A, B, C of the prism should be well defined. This perpendicular on face BC, and OL should be equal to OP. The other thing most important is to measure the angle P and Q. That should be accurately measured, and this is how we get the correct value of index of refraction.
You can take this book from the store or free downloading from my website. These readings are given as a reference. Your readings may be different from these readings.